Welcome everybody to this new session of the Network of Resources webinar series. I am Federico Rondoni on behalf of the Network of Resources, and I'm here today together with David Arthurs and Tina Dolezalova to talk about the Polar TEP. We will start in a bit. I just want to remind all the attendees that this is a session of the NOR webinar series, which is a webinar series aiming to present all the different services that are available through the Network of Resources. The Network of Resources is an European Space Agency initiative that aims to bring user to data. It means that we provide different resources that are available on all over Europe to work within the cloud environment and to handle data directly in the cloud environment. Today we are presenting, as I said, the Polar Thematic Exploitation platform, and we'll see in a bit. I invite all the attendees, if you have any question, to write them inside the chat. We will take the questions at the end of the presentation in a question and answer session. And after the question and answer session, we will also go through the NOR portal and the sponsorship process that is available through the NOR portal. And you can also see all the previous session of the NOR webinar series inside the outreach page of the NOR portal, but we'll see it in the end. And I also want to remind you that at the end of this session, there will be a feedback form available, and we kindly ask you to fill it in order to let us know how you found the webinar and if you have any suggestion to improve the webinar series. So without taking other time, I leave the floor to David. Please, David.
Thank you very much, Federico. First of all, can you see my slide properly?
Yes, we can.
Okay. So today we're going to talk about Polar TEP, as mentioned. We're going to dive down into two of Polar TEP's capabilities, the machine learning environment and the education environment. There have been previous Polar TEP sessions that have looked at other aspects of Polar TEP. So as Federico mentioned, please go back and see those videos. I'm going to start by giving just a quick introduction to Polar TEP and an introduction to the two capabilities that we're looking at today. And then Tina's going to dive into looking at code and the technical details of how to use these capabilities. So Polar TEP. If you're not familiar with the ESA thematic exploitation platforms, Polar TEP's one of them. We provide an environment to access algorithms and data remotely, computing resources and tools that you might not otherwise have, and in general allow you to work in the cloud rather than downloading huge amounts of Earth observation data. We are focused on Polar, but we're not restricted to Polar. We hold all of the Copernicus and other Earth observation data for the entire world. You can use our platform for work in any topic, any place in the world. It's just that we give special attention to our Polar users to meet their needs. And those users consist of communities that come from science and research, operations such as providing information to ships traveling in the polar regions, and northern communities, people who live in the north. And if you want more information on Polar TEP, you can go to our landing page, which is at polartep.polarview.org. So Polar TEP provides a whole lot of capabilities. Just sort of a brief overview: data access. So you can access all types of data, predominantly Earth observation data, a lot of large environmental model data, and specific in situ data to do with the polar regions. We can help with data preparation. We have a lot of tools for that. You don't have to reinvent the wheel. You don't have to download data. We can provide considerable computing power, both CPUs and GPUs, and specialized algorithms for processing. We can help with the dissemination of your results. We have a lot of tools now for so-called storytelling. You can get the word out better. And a recent focus of PolarTEP is in supporting open and reproducible science. So this is the idea of sharing, comparing, collaborating, sharing algorithms as well as data, and enabling others to take your research and build on it and reproduce it. We have a large number of capabilities. As I said, some of these have already been discussed in previous webinars. We have tools for data discovery, visualization, and interaction. We support programming. Most of our users are Python programmers, but we can support other languages as well. And most of our users do their programming in a Jupyter Notebook environment, but we can support other methodologies as well. We have an execution environment for doing mass processing after you've done your programming. And if you're only processing a small amount of data, you can do that within the Jupyter Notebook environment. But if you're doing massive amounts of processing, we can support Docker containers and headless execution. We support data cubes. As I mentioned, we have pretty considerable storytelling capabilities, and we support open and reproducible science. Today, we're going to drill down into machine learning and education. So our machine learning environment is based on MLflow and DVC. We as the tools to support that, and we provide access to GPUs. MLflow is a tool to streamline the whole machine learning development cycle, including tracking experiments, packaging code, deploying models, etc. And Tina will be demonstrating that. And then we have DVC, data version control, which tracks data sets, including the MLflow models. And again, Tina will be demonstrating that. So just to give you some ideas of what others have done with this. In terms of machine learning, just two examples. Last year, ESA hosted one of their AI for EO challenges called AutoIce, which has to do with using machine learning to automate sea ice chart production. We had 121 teams registered in that competition. 42 of them used PolarTEP to do their processing, almost 4,000 hours of processing time, and 6 of the top 10 teams used PolarTEP. Just I mentioned that the University of Waterloo in Canada were the winners. Another example, the National Research Council of Canada is using PolarTEP to look at their research on nature-based solutions for flood and erosion protection. They're processing Sentinel-2 data and using a foundation model to do that. And at the bottom of this slide, you can see a quote from their view of using PolarTEP. They were particularly enthused about the ease of use, about the API access to all of the EO data collections, the ability to change hardware, and in particular, the technical support we provide. I'll just mention that's mostly Tina, so well done, Tina. The education environment, we have a number of people who are using PolarTep in a university or other course setting. We provide custom environments for each course, which consists of a custom landing page, accounts for the instructors and the students, and then we populate that with any special data sets and libraries that they need. And the idea is that the students can do their exercise in a Jupyter Notebook environment. They can document their code. They can submit those notebooks to the professor for grading. We provide an environment for that sort of interaction. And it's been really popular and well received. A few examples here, University of Svalbard, Carleton University in Canada, and one of the ESA Science Cluster portions of it have been using the environment. Again, a quote on the right-hand side there from one of the course instructors about how well the use of the platform went, and the fact that they'll continue to use it, and in fact all of these people have been repeat users. So we're now going to move into the demonstration phase. Tina will be doing that, and there'll be, we'll first look at the machine learning environment and go over the things that are listed there, and then the education environment. Finally, I'll just mention that if you have questions, please get in touch with me, and we'd be happy to work with you in the future. So, over to you, Tina.
Thank you, David. Let me share my screen. I hope you can see it.
Yes.
Okay, perfect. I'm not sure if everyone here visited the webinar before, so I will start with the first and very short recap of what was shown last time. So as David mentioned, the PolarTep is allowing to connect to large amounts of Earth observation data and much more, and provides computational resources. If you would like to explore it on your own, you can navigate to polartep.hub.eox.at website and continue to set up your account. After registration, PolarTep community, mainly David, needs to approve your registration, and once the registration is approved, you will get access to a landing page which looks like this. Sorry, we got... you will get access to a Jupyter Lab environment where you can start your workflows. Jupyter Lab environment looks as a standard Jupyter Lab, but it has some additional features which are mentioned in the previous webinar, so I will not go into big details. But just very shortly, we provide a couple of selected kernels which are specific for PolarTep, and I will be talking about the specific ones for the machine learning in a moment. But they in general consist of a large amount of geospatial libraries and are freely available to all our users. And we also provide in the application section a notebook launcher with all the notebooks available from a Polar community. So you can explore all these notebooks and explore how they are actually using. So you can explore the size algorithm, and by clicking on the execute button, the notebook will get copied to your workspace, and you can modify it, you can run it, and you can even change the code and try to experiment with it. In the notebook section, you can also like the notebooks, or you can comment notebooks and let other users know your thoughts, and use this as a collaborative option. Another option for the collaboration is a Git extension, which will allow you to back up your work, and you can just work from a browser, from a terminal, or just from this extension to freely commit and contribute to a Git or GitLab or GitHub repositories. Now I would like to start with the machine learning features because that's the main topic of today's webinar. For today's webinar, I will be talking primarily about the ML Flow, which is a machine learning ML Ops toolbox allowing to track and make whole machine learning development easier by tracking all the experiments and tracking the models and exposing the models, and the DVC, where DVC stands for Data Version Control, and it is a brilliant tool for controlling large data sets in a similar way like Git is tracking your code history. For that, we have made the tiles available with the toolboxes available to all the users. MLflow and DVC are not tools available to all the users. These features need to be activated and you need to request it when you are applying for the resources. So once your account is approved and you ask for the AI capabilities and PolarTap community approves, you can get access to the MLflow and DVC and also the additional resources. Perfect. Both tools are very handy when you are building your machine learning workflows, because the MLflow starts with the tracking of all the experiments and the DVC comes handy when you need to track your datasets. And the PolarTap also allows you to display and visualize the data, which is something we covered in the previous webinar, so I will not go into much details this time. Let's start with the actual DVC. So as I said, DVC stands for Data Version Control, and to get you started, we have created an example notebook with all the instructions. For the DVC, we have created a couple of kernels which are working with it. If you would like to activate the kernel, you can type a conda and list to see what all kernels are available for your user. You can see that one kernel is called PolarTap DVC, and this is the one we will be using. So I will type, and I just realized that maybe it is too small, so I will make it bigger. So I will write conda activate and then the name of the kernel. And this way we get a PolarTap DVC kernel activated. What I forgot to mention is that the DVC is a command line tool, or that's how we use it in the PolarTap. And so all these commands written and described in the notebook are only for the command line. These instructions are covering step-by-step workflow from initialization in a Git folder, because the DVC is working together with the Git. So after initiation of the Git repository, we can also initiate the DVC one. By DVC get, we can actually get data from a public repository. So in this case, it is a GitHub example dataset. So the get function will download us data directly. And similar to Git, DVC is working with the remote. Remote storage is where we actually track all the data. And for that, we need some kind of a storage. It can be either local folder for the folder in a PolarTap, or as in this example, the S3 bucket. S3 bucket is another storage option PolarTap is providing for users, and then as a user you can mount it and have it as a folder, as you can see I have here. So this is my S3 folder. I can add my remote just by adding a DVC remote add, and I can even list it with the list option. The workflow for adding and pushing data to a remote is very easy. It follows a git add and then DVC add commands, and then git commit. So you can see that it might be a bit confusing. What is the distinction between the DVC and the git? But these two just works together very well. And to push into the DVC, we will use the DVC push command. All the files are then stored on the S3 bucket in this case, because that's how I set up my remote. We can actually explore it, because you can see here that I have here a DVC store, and inside I have a file. So I can even access them and modify them if I would wish to. This notebook is available to all our users who have access to the DVC, and this notebook is then available in the notebook section as well. Plus, as David said, we provide a technical support in case there are any questions. Now to the second tool which we were mentioning, and that's the MLflow. MLflow has a special tile here because it's a graphical interface tool, not a command line tool. I have it open here, and maybe I will start with describing a bit what is happening on this screen. The main menu here is separating the things into experiments and the models. The experiments is where we are tracking all our model training and data processing and anything. The experiment here is a MLflow word for different projects, or how we wish to separate things. You can see that I have here 4 larger experiments. So one is called initial coastline semantic segmentation, or we are having here one experiment for demo, and much more. I can open them, and I can see here various experiments directly in my window. Let me just scroll through here, and I can scroll through and you can see all the various runs being displayed here. The names are arbitrary, created by code, but you can name it in more human, meaningful way if you wish to. We also have here a timestamp when it was run, so you can track how the model creation was progressing over the time. What's important is the duration, and also the source notebook is stored here together with the information. Let me just zoom out a bit so you can see a bit more on the screen. And associated model. The model is the second important part of the MLflow, and that's the model registry. As a data scientist, you can probably agree that storing a model with some tags or labels is very important, not to store the models with just the name model best 1, model best 2, and that's where model registry comes very handy. After you are happy with your training, you can just do the model log function, and it will store into the model registry with a given name and also the version if it was already existent. So in general, you are not overwriting your latest model, you are just adding a newest version. You can also separate models into staging and production, and you can also see when it was last modified. If we open just one of the models, you can see that it has a text version, so how they were progressively added. And after clicking edit, you can even find more information or add some description or explore the model in more detail. Going back to the experiments, I would like to show you a bit more how the actual run looks like. And to do that, I can open one of the runs. You can also see that you can also check if the run was successful or not, which is already separating the ones we are maybe not that interested. We can track various metrics. So in this case, I can track the accuracy, F1 score, intersection over union, and many other metrics which might be important for your specific model. And I can also track the parameters. So in case I'm running multiple experiments with a different batch size, for example, they all will be logged here, and I can compare them. If I would like to compare them more visually, I can also compare them in the chart view, where I can add a chart and configure it with multiple information. So, for example, I know that my model score is assessed on the in intersection over union metric, so I can add it to the chart, and I can add it here. So I can have here visualized. Sorry, this is a train accuracy, so I can track it over the couple of models, or I can go back into the training intersection over union. I can compare much more, and I can also add more runs to it. So I can hide them, or on the other side add them, and I can add more metrics to this chart view. Now it's, I hope, good time to actually look how the MLflow looks like in the code. We have prepared another example notebook, which is showing how to connect to the actual running instance. The MLflow is working with storing data into a database, and in this case, we hide the complexity of that into the environmental variable called MLflow tracking URI. The important thing is to import the MLflow, and the rest is quite easy in Python. After setting up the tracking URI and setting up the experiment, if not set, it will lead to a default one. We can just simply start with mlflow.startRun as run, and we can start with the logging any metric we would like to. This simple example is not doing any machine learning or any statistical learning. It is just logging a one metric called metric1 with the value 1. This will simply be appeared here, here as another experiment with just single metric. MLflow comes with two basic modes. One is called auto logging, and the second one is the manual logging. MLflow supports many different flavors, supporting all standards machine learning and deep learning frameworks like PyTorch, TensorFlow, or from statistical learning, the scikit-learn library. And all these flavors are having the auto-logging option. That means that with auto-logging, everything is automatically logged, so you as a user do not have to think in advance what metrics you might be interested later, and you can only select later in the MLflow UI what you are interested in and what to focus on. To do that, I have here a very simple example with the TensorFlow, where we are setting up the flavor, so in this case TensorFlow, and starting the autolog. After this command, everything, I will, increase the size again. Everything after this autologging command will be logged and added to the MLflow. You can see that I'm here building a very, very simple model with just a sequential one with a couple of layers. And after training it, I'm printing the test score and test accuracy. This is actually in this scenario redundant because all this information will anyway be logged in the MLflow. The second option is the manual logging example, which is great if you are using some kind of a flavor or framework which is not so widely supported and you still would like to use MLflow. Or for example, you are using an older version of a PyTorch and that's no longer supported by the MLflow. Or you would like to just select separate features to log and not to have to deal with a larger amount of tracked options later. So in this case, I'm just using the scikit-learn model or scikit-learn training and using the manual logging. So after defining the metric function and loading some kind of a data, I need to type manually the with MLflow start run, so something you have seen previously, and then training the elastic net and then fitting it and trying to predict the values. I can manually do the log parameter to know what parameters were used for the training, and the log metric to actually log metric I'm interested in for comparison, everything into the MLflow. Once I'm done, I can also use the log model to actually upload my model to the registry. I can name it, so this one will be elastic wine model because it is the prediction on the wine quality data. In the auto-logging example, my model got logged into the MLflow automatically and I didn't have to do that manually. This notebook is available to all users who have access to MLflow, and again, it is available later in the notebook viewer. Since I was showing the MLflow with more complicated structures and many models, I can also show it to you in an actual more complicated notebook. which is using the MLflow. And this is going down to what David was presenting, and that's the detection of the sand mounts in the water in the Canada. So you can see there are lots of pre-processing tasks and also a lot of processing. But I would like to go lower into the actual model definition, and then when the training with the MLflow is being run. And this is actually here. So you can see that it is using the MLflow start run and then number of epochs. So all the parameters are logged with the MLflow log parameters. And it is also logging the artifacts to know the model summary. And it is logging all the metrics as a train loss and the validation loss. And it is comparing with the best model and saving on the best ones. It is using the PyTorch flavor to log the model, and in the end, it is also converted to the Onyx model. Onyx is an amazing format, highly supported by the MLflow because it is allowing the interoperability of the formats. So going back to this model, I can open it and you can see that all these parameters are here, which I was showing previously. So it is using the Adam optimizer, for example, and it was trained for 2 epochs. And all the metrics are recorded here as shown on the previous slides. If you have any questions regarding the MLflow or DVC or the AI capabilities PolarTap is supporting, just write the questions in the comments and we will get to them in the second part. Otherwise, in the meantime, I will switch to a second part, which is no, sorry, I completely forgot to mention one thing, and that's training of the model is a great thing, and once you are done, you might want to scale things up. For that, the PolarTap, as David mentioned in his presentation, offers a couple of features, and one of them is a data on demand. Data on demand is a let me switch the screen. Is a feature where you can actually apply the algorithm on a different region and get just the data available. You can trigger this functionality from the PolarView viewer, which was introduced in the previous webinar. So I will just quickly go on the section called on-demand data, and you can select one of the algorithms available here. This algorithm is called size, and it is producing the snow information. If you would like to select the resolution, you can also use the hint information, so it needs to be something between 300 and 1200. So I will just go with the 300 and creating the area of interest. You can go to the purchase, and that will redirect you to actual PolarTap website where you need to log in. You need to buy a credit because this feature is not for free, and you can obtain the results. You can obtain the results in a multiple way. One of them is you can download the data directly. The second option is the data can be stored on your PolarTap connected bucket, or it can be connected to other workspaces if you have it correctly set up on the PolarTap account. So this is one way how you can actually get the data, but maybe you have an algorithm you would like to offer for this onboarding, and that means you need to contact us, and we also put together a documentation. And if you would like to offer your algorithms as an on-demand data generation, we offer 3 options how to do that. So it can either be a Python notebooks, which are executable in the headless mode, or it can be an OGC application package, or as an OpenEO process graph. In any case, if you would like to have your algorithm onboarded as a data on demand, you need to get in touch with David and to go through all the all the steps with support of one of us or someone else from the PolarTap community. If you would like to just use your data and explore the options and scale things, you can also change your notebook, and in this case it really needs to be a Python notebook, and trigger them in the headless execution mode. To do that, I will just quickly switch to the second screen because I have it here prepared. And for that, you need to have access to the PyGeo API in the background. Your notebook can be stored in the extra folder, which is a special folder for this execution. And your notebook needs to be turned into the headless execution. To do that, the first cell needs to be tagged as a parameters, and that way our PyGeo API will know that this is the cell of the notebook I need to augment. In this case, I'm showing just a very simple addition function, which is summing a plus b and printing the result. So in this case, 1 plus 22 should print a 23. I will try to trigger a job in the headless execution job. And for that, I need to obtain a token. You can obtain a token if you go into the hub control panel and obtain a token in the token section. So request a new API token will get you one. I prepared my command here on the side, and I will right now trigger it. And in the meantime, while I'm waiting for my job output here in the with today's date, I can go to the PyGeo API result page and check if my job is running correctly. So it is telling me that it is running and it is actually successfully completed. After that, I can open the resulting notebook and I can see that I have overwritten my parameters with number 4 and 5, and then therefore the C is no longer 23 but actually 9. This is a very, very basic example where I have just sent the new parameters being 4 and 5. But this methodology can be used for larger processing or processing running over a couple of hours when you don't want to spend your time in front of a computer and run cell by cell, but you would actually like your job being triggered or run automatically in a more meaningful way. Okay, now I would like to switch to the actual second part, and that's the educational use cases. David mentioned a couple of courses, and I would like to show the TCCAS, which David, I believe, mentioned belongs to a science cluster from ESA. And I would like to introduce you to features we have done for them. One of the crucial features is their own landing page. So the URL is the tccas.hub.ux.at, which can be configured for each course separately. And they do not have to have an active PolarTap subscription for running the course. User can register, and here we provide to the course organizer two options. Either anyone can register for the course for a given period, or we need to manually approve everyone being registered based on the course students list we have received upfront. After registering to the course, the students get separate access to the resources. So you can see that they have a different profile with quite limited resources, but that's what we agreed on with the course maintainers. So just the 4 gigabytes of a memory and 1 CPU. After starting the profile, it will take just a couple of seconds. You can see that the Jupyter Notebook is looking similar or literally the same as standard PolarTap, but it has a couple of things specially configured. One big difference is also the access to the notebooks. but we offer a special shared folder for all our course teachers, because course teachers should have a space where they can work together on the materials or the coursework, and students should not be allowed to modify the results. So for that we have a folder, shared folder with a TCC-AC, and after exploring what is available, you can see that they have their own presentations and they have their own notebooks available, and these notebooks are then made available to the students through the main window. So you can see that they prepare the whole coursework consisting of 4 notebooks and also environmental setup and functions. And all this is only read-only for students and write as well for the teachers. Speaking of materials available for the course organizers, we also have a so-called Xcube tutorial. This is as an educational platform which was used in one of the courses, and it is covering a couple of learning objectives and also required skills and prerequisites, and going through many of the basic steps and manipulation with the Xcube and other standard libraries for handling geospatial and Earth observation data. Yes. One other things we have done for the courses, and it's also what we can do for any courses we are supporting, and that's special kernels. In this case, you can see that we have done TCC-AC kernels. We have 2, 1 and 2, and they are a bit special because, for example, this course requires to have Fortran programming language available, which is not a standard thing we are making available for everyone, but it was a requirement for this course, so we made it available for them. There is a huge flexibility we can offer to course organizers or students in terms of a combination of computational resources, kernels, or any additional tools they might need to, or additional data sources. We can also connect a bucket, a S3 bucket for them, and make more or larger data storage available if needed. Last feature which David was mentioning was automatic submission. For that, we have option to for students to set up online submission tools for their coursework, where they just with a simple click submit on the folder. I will show it here. So I have here connected a submission folder, and if I upload my finished coursework into the submission folder, and I can do here an upload, it will be uploaded to a bucket, and all teachers will have access to it and they can assess it. I'll return me with the comments, the coursework, and the students will be notified. This feature is very handy when it is a larger course or students need to submit something gradually. Okay, I think I have covered everything I was supposed to, David. Is it true? Or should I add something more?
No, I think that's great. Thank you very much.
Okay, awesome. Then I will stop sharing, but please let me know if you have any questions, or if you would like to, if you would like to know something more about the PolarTap, you saw David's contact details, so get in touch with them. Thank you.
Thank you, Dina. Thank you, David. I see that there are no questions at the moment in the chat, so please feel free to write in the chat if you have any questions. In the meantime, I will quickly share my screen, and I will go through the NOR portal. Okay, can you see it?
Yes.
Okay, thank you. So, how to reach the NOR portal? First of all, you need to go to the nor-discover.org web address that will redirect you to the Network of Resources homepage. Here you can already find some useful information about what is the Network of Resources, the number of approved projects, the number of service and providers onboarded, and so on. And you can also find useful information related to the latest for instance, providers onboarded, and also the past, as I said, sessions of the Network of Resources webinar series. So, if you go to the portfolio page and click to access it here, you will be redirected to the NOR portfolio, which is the place where you can find all the service available through the Network of Resources. You can then search the portfolio by going to the text search or to the filtering system, or you can just scroll down the list here until you find what you're looking for. For instance, in this case, we are looking for the Polar Tap, so we find it. And here we'll have some details about all the services and the collections available through this provider and so on, and the provider help desk link. This is really important because we always advise people to reach out to the provider first before asking for a sponsorship, because we want to know that the services you are going to ask through the Network of Resources are really helpful for your project. Then, by going to the pricing wizard, you can ask for specific services, either to the provider or to ESA. First of all, you need to select the project type you're working on. For instance, we have four types: commercial, research, pre-commercial, and educational projects. You have to remind that only research, pre-commercial, and educational projects are eligible for ESA sponsorship. So well, let's say we are working on a research project, and then here you have the list of all the different services available through the NOR. You can select one by clicking on the tick box. You can change the number of units and the duration of what you are requesting. And at the bottom of the page, you will have an overview of the cost. Then you have two different options. You can, as I said, ask directly the provider for the specific service by going to the provider website, or you can ask ESA for sponsorship. In this case, you need to select if you're working or not on an ESA project. Let's say we are not working on an ESA project, and if you will or not co-fund the cost. Let's say we are not co-funding the cost. This is important in particular if the amount of resources you are requesting exceed the maximum amount possible, that is 5,000 euros. Then you click on Ask ESA for sponsorship, and you will be redirected to a new page where you can put all the different details of your project, starting from the project title, your name as project coordinator, your work category, an official email address. This is really important because it must be an organization email address. It cannot be a personal email address like Gmail or anything personal. The project organization name, country, web page, and address. Then you have the fields related to the project itself, like project objectives, where you need to state which are the goals of your project, and the implementation methodology that you want to use to reach these goals, the expected results of your project, and the justification for selected services and provider. This is why we advise you to contact first the service provider, because we want to see why you selected the specific services. The description of work within the cloud environment. As I said at the beginning of this session, the Network of Resources is an ESA initiative aiming to bring user to data and not the contrary. So we want to see that you are going to work within the cloud environment. The geographical area of interest of your project. This is basically the area where you're working, on top you're working on. For instance, if you're working on a specific city or cities, regions, and so on. Then, if it's the first time you have applied for the NOR sponsorship, you need to select yes. If you select no, that it means it's not the first time, then you need also to write here the previous request ID that you had for your previous request. If you're working on an ESA project, you will have here more fields related to the ESA contract number, the ESA technical officer, and so on. And finally, you will have an overview of the different services you are requesting and the cost. The last things that you need to do are to select the expected date of submission of the set of slides. What is the set of slides? It is a PowerPoint or PowerPoint-like set of slides, usually 4 to 5, where you write how and why the services that you requested through the network of resources were used for your project. We don't want to see the final results of the project. We want to see how you use the resources that you requested through the NOR. Here you have to basically set a month and a year, and in that month you need to send this set of slides. Then you can or cannot sign up for the NOR newsletter. This is up to you, but you must accept the ESA privacy policy. Once you have done all of this, you can export the sponsoring request. It will create a PDF file. You download the PDF file, sign it, and if you are working on an ESA project, you have you need to have the document also signed by the ESA technical officer, and email it to nor-sponsorship-request@esa.int. This will trigger the evaluation process that usually takes around 6 working days, but it might take also a bit longer, in particular if we need more information. But in that case, we will come back to you asking for more information. This ends this part, so let's see if in the meantime we receive some questions. Okay, perfect. Thank you, Tina, for sharing. Also, as I said, the list of the previous webinar is available through the NOR portal under the outreach web page. And of course, the video are uploaded in YouTube, so you can also watch them on YouTube. This video will be available in the next weeks. So thank you, David. So for sharing the link. So you will also have the opportunity to rewatch this session. I want to remind you that next week there will be the last session of this series of the NOR webinar, and then we will have a summer break. And at the end of this session, you will receive, it will open a web page, a feedback form that we kindly ask you to fill out. So since I see that there are no questions, I want to thank again David and Tina for the presentation, and all the participants, and see you on the next session of the NOR webinar series. Thank you very much.
Thank you.
Bye-bye. Have a nice day.